This is a second video in dealing with game-based physics, and this one's going to be dealing with acceleration and acceleration due to gravity, projectile motion. So what we start with is I have a simple movie clip here. I'll call it Balloon 2, and we look at our action scripts for using ActionScript 3.0. And you'll see that we have some number variables. We have our y move, or our dy variable, and it starts at 0. And we have a mass as being 1, and force variable being 30, and force 2 being negative 31. We have a net force, so of force 1 plus force 2. So we have positive force as a downwards force, and our force upwards is negative 31 in the y direction. And we have our acceleration is our net force divided by our mass. So basically we're taking the physics F equals ma, or force equals mass times acceleration, or Newton's second law, that is an acceleration is due to a force being applied to a mass on an object. And we can see that we have a net acceleration, or we have a net force upwards of +1, or -1 would be upwards. So we have a function for this enter frame event where we have our y move is equal to our acceleration, and our y position is an addition of our y move. So we can see that we can use a regular physics equation here to derive a simple motion, accelerated motion. And so if we look at this control test movie, we'll see that object accelerates upward. Okay. Now we can use same type of motion. This is going to show that our gravity is a variable, and we have 0.0098, and we have a dx of 0.2, and we have a dy of negative 0.8. That means 0.2 is across to the right for our x motion, and our dy is -8, which means upwards. And we also have a variable which is an integer, a time integer. Get the timer, add listener event, enter frame, animate the ball, and we have time difference, our get timer minus our last time, and we have an addition of our time difference. All right, so the ball's going to move at different time integers, and our dy is addition of gravity times the time difference. Ball 2 is our movie clip, is named Ball 2, and our x and our y motions are the time difference times our dx motion, right, 0.2, or times our dy motion, but our dy also has gravity, which is 0.0098 added to it, and we will see when we do this that plus 0.0098 is downwards. So we have a ball that is accelerating upwards at -0.08, and it's going to have this downward acceleration taken out of it as it goes up, so it'll slow down and then it'll head downwards. So when we look at this control test movie in Flash, what we see is a parabola, or a very realistic gravity type motion, that you throw something up and then it goes downward. Something that's a little better, we have our the same Balloon 2 movie clip over here, but what we're going to do is we're going to add gravity. Object, its y motion starts at 0. Its x motion is +3, so it's to the right. We have a gravity, we're using a number of 2. We have our enter frame function, gravity bounce, And what we're going to do is we have our y motion, which starts at 0, plus equals gravity. So we have the addition of gravity, which is a number variable of 2. And our movie clip is equal to the x and equal to the y position. But if it gets to the bottom of the stage, not exactly to the stage height, but close to it, our y position is greater than 385, then our y position will equal 385, and we will multiply by negative 0.9, which means it will then bounce upwards, but not 100%, but at only 90% or 0.9 of the original motion that I had. And let's see, control, test movie, and we'll see that by using this code we can get a very realistic bounce, but it only goes up 90% each bounce that it goes up. So we can see that control, test movie, it always moves to the right at 3, but every time it bounces it only goes up 90% of the last time it went up. Now let's look at adding some friction. Right? So this is our Balloon 2 movie clip. So when we look at this code, we see that our x move is a variable number, 10 is what we give it. And gravity is a variable number 2, and then a mu is a variable number 0.2. And the acceleration we're going to use as a variable is mu times gravity, so it's 0.2 times 2. We add event listener to enter frame event. We call the function balloon roll. So it's an event, and if our math absolute value of x move is greater or equal to the absolute value of acceleration, which we have up here, if the x move is greater than 0, then we have a negative acceleration, or acceleration in the negative direction, which is to the left. Else if we have an x move that's less than 0, then we have a positive acceleration, or acceleration to the right. So in other words, if our motion is to the right, then we have an acceleration that's opposite the motion to the right, and that's called deceleration. It's called friction, is what friction causes. If we had it moving to the right, then we would have a acceleration that was positive, or if we had it moving to the left, then we'd have an acceleration that's positive to the right. All right, so our motion is plus equals x move, so x move is positive 10. So let's see, control, test movie, and we'll see that it goes to 0 and then stops. Okay. Let's look at adding friction another way. Same thing. We have a Balloon 2 movie clip, and the code we have for this is a lot smaller. We have our x move is equal to 10, and we have a variable that we're going to call decay, or the decay of motion is 0.95. Now this is simple, because what we have is we just have the motion is multiplied by the decay. So since it's 95% each time, for each time it enters a frame, you only get 95% of what it was before. It will eventually go to 0. All right, so let's look at this decay. Control, test movie, and we have the ball rolling until it finally gets to 0 here. So this appears to be as a rolling friction that takes place. A little more subtle and a lot easier to write in code, and a lot easier to explain, because you're just having 0.95 of original. So every time it enters a frame, it goes from 10, and then you take away 0.95, and you have 9.05, and then you take away the 9.95 for each time it enters the frame, until you get it to the x position moving. It moves so small it's up to 0 till it's rounded to basically 0. So that's a good way to add the effects of friction to a game. All right, so let's look at now we're going to start looking at projectile motion. We're going to look at a flat-based cannon, and let me put this over here. And so let's look at what we have. I have a movie clip that I'm calling Gun, and this is this particular segment or section is again from Andy Harris's book Beginning Flash Game Programming for Dummies. You can go to his website and get the codes for ActionScript 2.0, but these have been rewritten in ActionScript 3.0. And if you get his book and read about this, he goes a lot more into depth about how the code has been put forth. So it's a good way to learn about Beginning Flash Game Programming for Dummies by Andy Harris. And this is chapter 11. We have vectors and gravity. So we already went over some of the principles of vectors in the first video, introduction to game-based physics. And so I have a movie clip that I gave the instant name of Gun, and then I have a movie clip that I gave instant name of Bullet. I have static text for direction, static text for charge. Then I have a dynamic output text box that I name angle_txt, and I used device fonts, and I embedded Arial font. And then over here I have charge_txt, dynamic output text box, and I used device fonts, Arial. And we look at the code here. Alright, so I already in previous videos I discussed how to use the keyboard events. So I'm going to use a spacebar, left arrow, right arrow, up arrow. So the arrows are in the bottom right hand corner of your keyboard, and the spacebar is on your keyboard. I'm going to use Boolean variables, which means when you start, it's false because none of them are pressed, and when you press them, then it'll be true. So there's only two states for a Boolean variable, and true is when it's pressed, and false is when it's not pressed or released. Alright, so some other variables I'm using is the gun direction will start at 0, which is straight up. The gun charge is a variable number I'm creating, which will start at 0. The bullet dot direction is a number variable, 0. Bullet dot speed is a number variable. Bullet dot dx is a number variable, and bullet dot dy is a number variable, all given 0, 0, 0, 0, 0. I add my keyboard listener events, and then my check keys enter frame listener event. And then I have my function, the canon physics, which is a enter frame listener event, frame based. So I name the key press down. Key code 37 is my left arrow, and when it's true, that'll be my key press down function. Key code 39 is the right arrow. That's true. Key code 38 will be the up arrow. Key code 40 will be the down arrow. And key code 32 is the spacebar. You can use any keys on your keyboard, but you have to look up the numbers to find out what key codes correlate with what letters or numbers or symbols that you happen to use. All right. Now, if they're false, that's when the keys are pressed or up or released, and we have the same key code numbers because we have the same right arrow, left arrow, up, down, and these will all be false if they're released. So when they're pressed, they're true, and when they're released, they're false. Next thing we have is we have our function for checking the keys. When the left arrow is true, our gun direction will be negative, negative, or be taking away, and our gun rotation is equal to our gun direction. So what will happen is our gun will rotate to the left when you do the left arrow, and you'll take away each time for each frame it enters that the button's pressed. Our gun direction with the right arrow will be positive, and it'll rotate to the right direction, all right, as that adds. When the up arrow, you'll have a gun charge that's added, and when you have the down arrow, you'll have a gun charge that becomes less. for each frame that it's pressed. And if you press the space bar, then the bullet.x will equal the gun.x, and the bullet.y will equal the gun.y. So what you'll have is you'll have the bullet, which is over here, for just so you can see what happens, will be taken and dropped at the center point of the gun, and the direction will equal the gun direction, so the bullet direction will equal whatever the gun direction, and the bullet speed will equal to this gun charge variable that we have increasing or decreasing with the up and down. Right, so now we run our cannon physics. We have the move bullet and the turn bullet functions. Right, the move bullet is that the x position is the addition of the bullet dx, and the y position is the addition of the bullet dy, which starts at 0, and we'll see that the bullet.x is greater than stage width, then or if the bullet.x is less than 0, or the bullet.y is greater than stage width, then we will replace the bullet over here at -100, -100, somewhere off screen, and the bullet speed will be 0, so it just sits there and waits for the next time we use it. Alright, our turn bullet function, we have our variable of degrees and radians, and our bullet.direction -90 will give us our degrees, and then our radians is degrees divided by 180 times pi, 3.14. So our bullet.dx is equal to the math cosine of the radians times the bullet speed that will be determined by the gun charge that we add by pressing the keys, and the bullet.dy will equal the sine of the radians times the bullet speed, and the angle.text is equal to the negative gun direction plus 90, and the gun charge.text is a string of the gun's charge. So whatever our gun charge is, by pressing the key, it'll be displayed in our dynamic text box, charge_txt, and whatever our gun direction is, determined by pressing the keypads, what we'll do is we will have the negative of the gun direction plus 90. And what that gives us, negative of gun direction gives us that this will be 0 and then this will be 90, because right now this is actually the 0 gun direction, and we want to be more in sync with what we learn in school. This is 0, straight up is 90, this is 180, this is 270, and then 360 around the side. So if we want those numbers to be more like what we see in a math textbook, then we're going to do a little we're going to have negative direction plus 90 to give us those numbers. So let's control test movie in Flash, and now I'm going to do the keypad. So right now it's at 90, there's our bullet, there's our gun, charge is 0. So if I push the up button, you see the charge goes up. If I push the down arrow key, then it goes down. Up, arrow key, up, down, down. This is how fast it's going to be. If I go to the right, it turns to the right, and like I said, because of the way I put in the equation there, that negative plus 90, this over here is 0, and then if I go this way it becomes negative, and if I go to the right it adds up all the way till it goes to 360. Now when I push the space bar, you'll see this. I'm going to push the space bar, this will disappear and it'll shoot out here. So I push the space bar and there it goes. Let's go this way, push the space bar, there it goes. So remember, 100, negative 100, negative 100 is somewhere in this area. So the bullet's sitting here now. Once it goes off the screen, it sits there. I can go in a full circle. So it goes up by 1. I'm just holding my finger on the key. So if you do this, you can figure this out yourself. And it shoots. Now, you want to make a game, you can add collisions. You can have that bullet collide into something and have it explode. We can look at that with another game that we're going to make using monsters and cars from the Beginning Flash Game Programming for Dummies book. Let's look at the next one from the book, which is called the Gravity Trace. Now what we're going to do for this one is we still have, let me come over here, make that small. So we still have our angle dynamic output text box, angle underscore text, use device fonts, it's embedded. We still have our charge, we still have our gun movie clip, we still have our bullet movie clip. We can move these things around all over the place, anything we want to do. So what are we doing now? Now we're going to add gravity to it, and gravity is going to be downwards. Right? So I'm still going to do all of this with our keys. So we still use our left arrow, Boolean variable, false, right arrow, up arrow, down, spacebar. We still have our gun direction, 0, gun charge, bullet direction, 0. But now we're going to add a variable called gravity, and we're going to use a number 1. We can use any number we want because we're naming this variable what we want it to be. So you're just going to use a number 1 for this, and it'll work fine. We still have our keyboard events for when our keys are down and when our keys are up. Pressed down, pressed up. We still have our check keys, and we still have our main function canon physics, but we're going to change some things here. All right, so this is all the same. All of our Boolean variables are going to be true for the key codes are going to be the same for the keys we want to use, the arrow keys and the space bar. All our Boolean false, same key codes, all going to be the same things here, so that's the same. Our check keys, all right, so for the start of our check keys, our direction and rotation is the same. Negative to the left, positive to the right, just like we had before. Up arrow is our gun charge, down is our minus charge. But we're going to do something a little, we're going to add something to this, just to show what's going on here. So we have our space bar. When we press it, we have our X location is equal to gun, so the bullet's going to be at this point, which is a registration point for the gun. Our bullet Y is going to be at this point where there's a registration for the gun. Our bullet direction is equal to the gun direction. Our bullet speed is equal to the gun charge that we have from our keys. And now we're going to add a line. We're going to add a graphic. It's going to draw a line. So the first line here is when I press the space bar, it's actually going to clear any graphics that are on that have been placed on the screen. So for the first one, we won't see anything, but now you'll see when I do this next time. Every time you press the space bar, it'll clear the old graphics. Graphic.line style 2 represents that we're going to draw a line. Okay, this 0, 0, 0, 0 represents that's going to be a black line. This 100 is the alpha. So 100 is solid, 50 is kind of see-through, and 0 is invisible. 2 is how thick the line is going to be. So it's going to be a thickness of 2. And if you ever use the line tool over here, you'll know what the thicknesses are just by clicking on this and then using the stroke over here. So 1 is a regular line, 2 is a thicker line. And then graphics to move 2. So it's going to start at the gun.x, gun.y, and then we're going to run the program, the turn bullet, after that. So our turn bullet, what we're going to see down here, a turn bullet function, is pretty much the same thing we saw before. Where we had the variable degrees and the variable radians, bullet direction minus 90 degrees variable is going to be divided by 180 times pi, which is 3.14, and our bullet.dx is going to be the cosine of the radians times the bullet.speed, and our bullet.dy variable is going to be the sine of the radians times bullet.speed. And we have our function here. So after we wrote our key check function, we have our canon physics, and we have our move bullet, and then we have that our angle text is going to be the string our negative gun direction plus 90, and that our charge underscore text is going to be the gun charge. And now we have our function move bullet. So our bullet.x is equal to the bullet.d plus equals the bullet.dx, and our bullet.y is going to be plus equals the bullet.dy. So you're going to have that increase, that the bullet x and y positions are going to increase by dx or dy as every frame goes through. And we have the rest of this line 2 graphic that we're doing. So we had our line 2 started at the gun XY position, and it stays with the bullet.x, bullet.y position as the bullet moves. So it's going to redraw it from the last position to this position each time. This all stays the same. That when the bullet goes off the stage, at that point the line will have a 0 thickness and will have a 0 alpha, which means it'll be invisible. So it'll still be, we say it's still going to be a black line. We can actually change the color because it has no thickness, which means it doesn't really exist, and it has a 0 alpha. So we have the bullet height, but this is something new I put in here. So since we have gravity, it's going to drop down, and when it gets to the bottom of the screen, which is the stage height, it's going to bounce back up. It's going to turn negative, but only at 80% or 0.8. And then the gravity is going to pull it down again. So we're going to have a bounce function. And that's the bullet.dy also has the addition of gravity, acceleration due to gravity added to it. So that's all the code that we have in there. So let's take a look at what we have here. Control, test movie, in Flash. So this drops automatically. Let me move this over so we can see that happen. So the bullet has gravity working on it. Control, test movie. So if you remember, we saw this in the last movie, that you bounce, gravity pulls it down, and then it hits the bottom and it bounces. So I hit the up key and the charge goes up. I hit the angle and it goes over a little bit. And let me get it up to 30. Right, so now when I fire it, zoop, it went off the screen, but I didn't have it die when it got up there. And you can see it bounces, but it's only 80% as high as it was before. It should be 80%. Looks more like it's 60%, but you can play with those numbers to make it look at how much impulse momentum you have when it bounces back up again. But now notice I have this line take place. So what I put in the code here was that when I press the spacebar, I will clear all this drawing. So I cleared it, fired it again. I can move this down to 22, clear it, fire, and you can see this bounce, and it bounces off the stage. So you can have a lot of fun with that. Sometimes you get these little hiccups in there, but that's okay. So that is the gravity trace, and I added a bounce to it, which is a little different than Andy Harris's code was. But I like the way that looks. And then last one we're going to do here is we're going to do the same program here, but this one we're not going to use the key codes for, and we'll see that we let me minimize this. Oops. All right, so we have our static text, we have our angle underscore tx dynamic output, we have our charge dynamic output, but we also have our dx underscore text and our dy underscore text to look at the x and y positions. We have the bullet still with the gun still, and let's open this up and look at the code. When you write these mouse events, Flash actually puts this. You can type this in, but it'll actually put this in itself automatically when you're using these. So we have our import Flash events, mouse events, and our gun direction. All of the stuff is the same. Gravity is all the same, but we don't have our keyboard. We're not using the keyboard. It's going to follow the mouse around. So we have our mouse event click to fire the cannon, and we also have our enter frame event in cannon physics. So the cannon physics is when it enters the frame, we're going to have the cannon follow the mouse. We're going to move the bullet, and then we have our angle text and our charge text dynamic output text box give the strings of the gun charge and the gun direction of the gun or the cannon. And we also are running the follow mouse, which is that variable. We have a dx and dy, and it's a number variable, and that's the mouse position x minus the gun dot x, and the mouse position y minus the gun dot y will give us our dx and dy variables. Those will be used to move the bullet. So the closer you are to the cannon, the slower it goes. The farther away you pull from the gun, the greater the dx is, and the faster it moves in the x position or the y position. We have the same. We have radians is the antitangent of our dy divided by our dx, and our degrees and radians times 180 divided by pi, and degrees plus 90. Okay, and our dx, if our dx is less than 0, then degrees is negative 180 or minus 180. The gun direction equals degrees, and the gun rotation equals degrees. In other words, the gun rotation equals gun direction, like we've been doing in the previous ones. Our variable distance is math square root, so we have our c squared equals a squared plus b squared again. So our distance is the resolved distance between the two vectors dx and dy, and our x component or y component of the distance. So we have our Pythagorean theorem, which is c squared equals a squared plus b squared, and we have to find the resultant distance, we have the square root times dx squared, or dx times dx, plus dy squared, or dy times dy, and the gun charge is this resultant distance divided by 10, and we have the text string for dx dy being output when it goes through here. Move the function. Alright, so we have a x dx position, y dy position. If it runs off stage, we put it to the -0 position, the y negative position, and the bullet speed is 0. So our bullet.x is negative x position, negative 100 x position. Our bullet.y is negative, and then it just sits there. If it hits the stage height or the bottom, it bounces at 80%, or negative bounces back at 0.8. Of course, our bullet dy is still plus equal to gravity, and for the fire cannon, it's a mouse event. We're going to when we click, okay, we already said that in the function, that when we click it, it fires the cannonball or the bullet. So this is the same thing we had when we had the space bar, and then the turn is exactly the same also. Alright. So you can see it follows the ball around, follows the mouse around.
Yeah, it does follow the ball around and the mouse around, doesn't it?
You press the...
Yeah, you press the button, you know?
And it fires.
Yeah, it fires, yeah. It might...